And we're back to Common Core Algebra II. Today we're going to talk about 11.8, which is the tangent function. Now here we are in the middle of the trig unit, which is my favorite, and I think I've probably mentioned that once or twice. And so many of you are doing really well with this, but please remember that if you're not, and this is confusing you because this is really very new to Algebra 2 and to you, and sometimes only 10 minutes sitting one-on-one with a teacher. It does not have to be me. You will not hurt my feelings. If you want to go to another teacher after school, the homework center is open, so please make sure you're using it and taking advantage of it and getting your homework done. All right, so 11.8 is the tangent function. So if you remember from Common Core Geometry and your right triangle trig, the tangent is the opposite over the adjacent. So looking at the triangle to the right, you can see how the opposite side is the side like across the street from you, if you think about you being theta and the adjacent, the opposite being your neighbors. Opposite is across the street, you can't touch them, but an adjacent neighbor might be one that you might even share a wall with, and in this case you actually share a wall of the angle with it. All right, so keeping your sides, and remember this is always your hypotenuse, it's the longest side and it's opposite your right angle. So taking a look at exercise 1, for each of the following right triangles below, state the values of the sine, the cosine, and the tangent of theta. So looking at this one here, well, if I'm going to do the sine, the cosine, and the tangent, I know the sine, well, drop my pen. Let's say the sine of theta, be a little bit more appropriate. Sine of theta, cosine of theta, and the tangent of theta. Going back to what you remember about SOHCAHTOA, or if you just remember that the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So if you take a look here, we don't know what the opposite sine is. So you might look, and if you remember geometry really well, you might say, oh, this is a Pythagorean triple. It's a 3, 4, 5 right triangle. But if you're like most kids, you won't remember that. And you have to kind of go off to the side and say, well, how do I find the missing side of a triangle if you have the other two sides? And you have no idea what the angles are. So hopefully you remember, the Pythagorean theorem, which says a leg squared plus the other leg squared is equal to the hypotenuse squared. So 16 plus x squared is equal to 25 minus 16 from both sides. X squared is equal to 9, and take the square root of both sides. And x is technically equal to positive or negative 3. But because we're talking about a distance here, where we can't have a distance aside of a triangle being negative 3, x is positive 3. So now we can continue with our sine and cosine. So we know this side is 3. So the sine is going to be 3 over 5. The cosine is 4 over 5. And our tangent is going to be opposite over adjacent, which is 3/4. Now you have to do the same thing with B, because again, we are missing a side of our triangle. Let's call it X. All right, so remember 2, I always circle the hypotenuse so I always remember it goes by itself. It's like the big sister that wants its own room, all right, or her own room. So we have side squared plus, or leg squared plus leg squared is equal to the hypotenuse squared. X squared plus 1 is equal to 4 minus 1. X squared is equal to 3. And when you take the square root of both sides, we're just going to leave this as x equals radical 3, or rad 3. So sine of theta is equal to the opposite over the hypotenuse, which is, this is rad 3, which is opposite, which is rad 3 over 2. The cosine of theta is equal to the adjacent over the hypotenuse, which is equal to 1 over 2. And the tangent of theta is equal to the opposite over the adjacent, which is rad 3 over 1, which is simply rad 3. hopefully you're also looking at this and saying, hey, I know these numbers. Okay, what angle gives me a sine of radical 3 over 2 and a cosine of 1/2? We're going to talk about that in just a minute. So moving on, consider the unit circles shown below and answer the following questions based on this diagram. If xy represents a point on the circle, how can we define the tangent function in terms of this point? All right, so let's just pull up. So here's my point xy right here, and here's the triangle that's associated with it. So you can see how the two sides are going to be the opposite side is y and the adjacent side is x, right? Because that's what the point is. From here to here is x, and from here to here is y. That's how we defined it. So we can say the tangent of theta is equal to the opposite side, in this case, which is y, over the adjacent side, which is x. B says, given how we define sine and cosine, how can we define the tangent function in terms of the sine and the cosine? Well, we just said that the tangent of theta is equal to y over x. And if you remember, the y was the value of sine, and the x was the value of cosine. So the tangent of theta is equal to the sine of theta over the cosine of theta. And right underneath here, I actually write that out for you. Oops, I need this here. So this is the next thing on your page. The definition of the tangent in terms of sine and cosine, tan theta equals sine theta over cosine theta. Now, when you get down to exercise 3, use the unit circle and the definition of tangent in terms of sine and cosine to find the value for each of the following. Do not leave any complex fractions. So if you take a look at these angles, we have 60, we have 45, we have 180, which is a quadrant angle, and we also have 150. So that's where this little handy-dandy little table comes from. Now, the 0, the quadrant angles, I still get from my unit circle. All right, my unit circle. I always know this one is 1, 0, and the rest of them follow suit. And I know this one is negative 1, 0, and I know this is 0, negative 1. Whoops, positive 1. I know this is 0, negative 1. All right, so I know here that the sine of 0 degrees, here's my 0 degrees right here. My sine is my y value, and my cosine is my x value. And at 90, it's right here. My cosine is 0, and my sine is 1. So I can get those right off my unit circle. Now, when it comes to the 30 and the 60, I always tell you, remember one of the 4 numbers, or actually there's only really 2 involved here. Always remember that the sine of 30 degrees is 1/2. And then the rest of them fall into place, because the number that toggles with that is radical 3 over 2. Sound familiar? Because that first triangle that we looked at was a 30, 60, 90 right triangle, and that's where those numbers come from. All right, so now, but we didn't look at the sine being 1/2, we looked at the cosine being 1/2, which means if you switched it, radical 3 over 2 is the sine of 60 degrees, and 1/2 is the cosine of 60 degrees, and 45 is the easy one. They're both the same. They're both rad 2 over 2. So you have to be able to, in order to find all the angles in exact format, you have to be able to generate that unit circle along with this chart with 30, 45, and 60. Because the rest of them will use reference angles that associate with that and which quadrant they're in. All right, so now using this, let's take a look at exercise 3. Use the unit circle. We talked about this already. So let's talk about the tangent of 60 degrees. So I know the tangent of 60 degrees is equal to the sine of 60 degrees over the cosine of 60 degrees. Well, the sine of 60 degrees, I'm going to slide this up just a little bit. Hopefully I can keep this there. I know the sine of 60 degrees is 1/2. And I know the cosine of 60 degrees is, oops, I just did that wrong. It's sine of 60 degrees is radical 3 over 2. So sine of 60, radical 3 over 2. So I know I'm going to run in here, but radical 3 over 2. All right? And then I know that the cosine of 60 degrees is going to be 1/2. So when you have a complex fraction like this, the bottom numbers cancel out. Remember, state change flip? So those would cancel out. So this would just be the square root of 3, which we found out in our first triangle. Remember we talked about it? We said the tangent, the sine of the angle was radical 3 over 2. The sine was 1/2, and then the tangent was radical 3. So you could go back to your triangles if you needed to. All right? So 45 is simply going to be the sine over the cosine. So this one's going to be rad 2 over 2 over rad 2 over 2. And anything over itself is always equal to 1. Now, this one gets a little complicated. The tangent of 150, figure out what that means. I'm going to come up here. Tangent 150, what quadrant am I in? I'm up here in the second quadrant, which is negative, positive. So tangent, so this is going to be negative, right? Because, and what's my reference angle? If this is 150, I need 30 more degrees. So this is going to equal, cosine is negative, sine is positive. So it's going to be the sine of 30 over the negative cosine of 30 because of that reference angle. The sine of 30, I told you always remember that one, is 1/2 negative radical 3 over 2. So this becomes negative 1 over radical 3, which we really should rationalize to negative radical 3 over 3. And the tangent of 180. Well, 180 is sitting right here on my unit circle. It's negative 1 comma 0. So I know that this is going to be the sine over the cosine. The sine is 0. The cosine is 1, and 0 over anything is equal to 0. Sorry, I should have left a little more room in there. I'm going to have to make some revisions for next year. So moving down. Because the tangent function involves division, there is a chance it could be undefined. So consider the angle theta equals 90 degrees, or in radian form, it's pi over 2. State the values of sine and cosine at this angle. Well, we have it up here, so let's slide up. Let's look at our unit circle. 90 degrees. Right here, 0, comma 1. So I know this is going to be 0, 1. So therefore, I know that the cosine of 90 degrees is 0, and I know the sine of 90 degrees is 1. All right, so why would the value of the tangent be undefined? Well, the tangent of 90 is equal to the sine of 90 divided by the cosine of 90, which is equal to 1 over 0. Oh, that's why, because the cosine is 0, which is in the denominator. So why would it be undefined? Because you can't divide by 0. Because then you would write this out. I'm not going to spend time doing that, but because your cosine of 90 is equal to 0, your tangent will be undefined. Okay, moving on to exercise 5. So now, which of the following is the tangent undefined? So looking at our exercise 4, we have to see where the cosine is going to be 0. All right, so let's go back up to our unit circle. I'm sorry to go back and forth. I'm probably making you a little dizzy. And I'm looking for where the cosine is 0. And as you can see, the cosine is 0, like we just determined, at 0 and at at 90, or pi over 2, and 270, which is 3 pi over 2, or 1.5 pi. So let's slide back down and see if any of those possibilities are here. So we just said at 90 and at 270, they're going to be 0. So at 0, it's 1. That's going to be 0. That's okay. Oh, we just said 270. So this one works, but I'm going to check the rest of them. 120 isn't even a quadrant angle, so having a 0 in my answer won't be a probability. And again, this is going to be one of my x-axis angles, so my answer is 270. So on a final note, it's interesting that we know sine or cosine of an angle, and the quadrant the angle, we can find the other two missing trigonometric functions or values. All right, so determine the value of cosine theta and tan theta if sine theta is 5 over 13 and the terminal ray theta lies in the second quadrant. Well, there are two ways to approach this. The first way you can approach it is graphically, like you can think about it as a graph. So you can think about it like this. If it lies in the second quadrant, you know that it's going to look something like this, right? You know that the sine is the opposite over the hypotenuse. So you know the hypotenuse is going to be 13. The opposite side is going to be 5, and we want to know what this side is. All right? So you can use that, or you can remember that this is the same thing. All right, so this is going to use the Pythagorean theorem because we're going to drop a perpendicular here to get that right triangle, or you can use your trig identity, which you remember was sine squared theta plus cosine squared theta is equal to 1. So if I know that my sine theta is 5 over 13, I know 5 over 13 squared plus, why don't we say x squared is equal to 1. So you get 25 over 169 plus x squared is equal to 1. Now you have a calculator. Don't flip out from the fractions. All right? So you get x turns out to be, so you do the math here, you get x squared is equal to 144 over 169. So x turns out to be positive and negative 12 over 13. But in this case, we're just going to consider the positive, which is 12 over 13. So I know that the sine is going to be I know this side has to be 12. All right. So it says here x is going to be my cosine. So I know that the cosine of my angle is 12 over 13. Or you could have done it using your Pythagorean theorem. You could have said 13 squared is equal to 5 squared plus x squared, and you could have solved for x. You would have got x is equal to 12. That's this. So what's the tangent? The tangent is going to be the cosine is going to be the adjacent, which is a 12 over the 13. Two ways to do this. I like using this better, but then again, we are two different people. So whichever way you like to do it, that's what matters. One last problem to consider, and then you're done for the evening. If cosine theta equals a, where a is greater than 0, so what does that mean? That means a is positive. And the terminal ray theta lies in the fourth quadrant. So already I'm thinking, let's say fourth quadrant is going to be positive, negative. Then which of the following gives the value of the tangent theta in terms of a? All right, so I know that my Pythagorean triple is sine squared theta plus cosine squared theta equals 1. And I know that the cosine of my theta is a. So again, I'm going to call my sine squared theta x. So x squared plus I know that cosine squared theta is a squared, because cosine theta is a, is equal to 1. So now what am I solving for? I'm solving for x. If you don't know that, look at your answer choices. They all have a's in them. So we have x squared is equal to minus a squared from both sides. So 1 minus a squared. And then we take the square root of both sides, right? So I get x, which is my sine of theta, is equal to the square root of 1 minus a squared. So now that means that sine of theta has to equal. Now, what is my sine? Look right here. This is why they tell you fourth quadrant. The sign has to be negative. 1 minus a squared. So the answer is number 2. So be careful. People, even if you did all that math correctly, you could have chosen number 3 if you totally ignored the fact that this was in the fourth quadrant and the sign is negative in the fourth quadrant. They tell you everything for a reason. All right? That's why they told you your cosine is positive. A has to be greater than 0. Okay? Be safe, be well, make good choices, and I'll see you next time.